All right, so now we will be working with, these are the antibiotic discs. So we have lots of different ones. So like, see if you can see it. This one's penicillin. So I think a lot of people know what penicillin is, so we'll do that one. This one's chloramphenicol. And I'm probably gonna butcher all of these names. This one's streptomycin. That's a pretty common one, so we'll do that one. This one's neomycin, so that would be the same category, so we won't do that one. This one's ampicillin, which I'm not sure, but it sounds like penicillin, so maybe we'll skip that one too. This one's kanamycin, so we won't do that one. This one's tetracycline, which, there we go. Tetracycline, so we'll do that one too. It's very well known. This one's erythromycin. So I'm only gonna do one that says mycin. This one's novobiocin. I might do that one. I don't know about that one. And this is another penicillin. So yeah, I'm not gonna do the novobiocin. So I will be doing penicillin, streptomycin, chloramphenicol, and tetracycline. So, and it's been a little while, so I'm going to re-sterilize my forceps just to make sure. Alright, so our goal is to get the discs in the center of each of these quadrants, and it is fairly difficult. It's really easy to for these to just kind of go flying, but the best way I've seen to do it is to push it off to the side a little so that you can grip just one disc. Man, this one's in there. And just grab one. Oh my gosh. Alright, so I grabbed one, and so you'll want to place it right in the center of one of the quadrants, and then just push it down so that it's flat, but you don't want to push it into the agar. So I'll do a second one for the other culture. So just have to get a good grip and then pull it out. And so if it falls on not on the spot that you want, you have to just leave it wherever it is, so that you actually will get a zone of inhibition and nothing will interfere with your results. So we've done penicillin. Now we will do the streptomycin. So you just push it and then grab it. So that one was a lot easier. So this one didn't fall exactly where I wanted it to, but hopefully we'll still see a good zone of inhibition. It's a little too close to this one, but it is what it is. So just push it out and then grab it. And we'll stick it in this quadrant and just place it down. So now we are ready to do the chloromenical. So you just push it to the side. Well, this one didn't work, but I was able to grab it, so not too bad. And then, so yeah, these ones aren't, so see, it's like at the end, there's only like a few discs left, so it's a lot easier to grab individual discs this way. All right, so now we are at tetracycline. So we'll push it out and then grab it and put it onto our plate. And we'll do that again for the second one. All right, so now we have our antibiotic discs on every 1/4 of the plate, and we'll put those in. So I'll put all of these into the incubator and incubate them for 2 days, and then we'll be back to observe the results. All right, it's been 2 days, so now we can go over the results for our Kirby-Bauer assay for antimicrobial susceptibility experiment with the antibiotic discs. So this is the staph epi, and this is the E. coli. So the main trends that I see are that the staph epi was not susceptible to streptomycin, whereas the E. coli was. And the E. coli was susceptible to tetracycline, whereas the staph epi was not. And then it looks like both of them were susceptible to the chloramphenicol. And so now we'll just go over them individually. So I'll just draw the zone of inhibition for each one, and then we will measure them. All right, so for staph epidermidis, so I circled the zones of inhibition that I could see. It didn't appear that staph epidermidis was inhibited by the streptomycin or the penicillin. But it looked like for tetracycline there was a small zone of inhibition, and for chloramphenicol there was a large zone of inhibition. So it kind of goes off the plate. So I might measure from the center out and then double that for the diameter, or I could measure this way. And then the tetracycline, I'm not even sure if that was a zone of inhibition. It's just a little clearer right around the disc. We will measure it anyway, but I'm not sure if that's really a zone of inhibition. So let's just measure this at its largest point. So this looks like it's 42 millimeters for the chloramphenicol and 10 millimeters for the tetracycline. So now we'll go over our results for the E. coli. I'll quickly draw out the zones of inhibition. All right, so this is where I saw the zones of inhibition, it didn't look like penicillin inhibited the growth of E. coli, but the tetracycline really did, and the streptomycin did pretty well, and then the chloramphenicol did, but not to the same extent as the staph epidermidis. So let's measure these. We'll start with the chloramphenicol. So it looks to be about 22 millimeters. The streptomycin, it's about 26 millimeters. And then the tetracycline, oh my goodness. It looks to be about 50 millimeters. But what we could do is also just measure from the center of the disc. So that's about 22, 23. So it's probably a little wider this way. So that would, if you double 23, it'd be 46 millimeters. So it looks like we'd probably want to redo this one with just one disc on one plate so we could actually see the full zone of inhibition. But so the tetracycline is definitely inhibiting the E. coli growth